Hi and welcome to the 10 square meter workshop. Recently I made a double rotary blast gate, see the link below, for my dust extraction system. Now I need to make another more conventional gate for my bandsaw. Coming up after this. I needed to make a slightly larger 50mm gate to go to the bandsaw, but I also needed a bend to direct the output towards my extractor. Plus I needed a 40mm inlet to go to my overhead system. I decided to put them all together.
First I needed to make the right hand side of the gate, with the junction flowing into it. Modelled in Fusion 360 and printed in white PLA, it was easier than I anticipated. The other side is simpler, made to take 50mm waste pipe. The motor force will be a gearbox motor unit widely available. This is a 1:100 reduction model. The gate separators are shown here with a sliding gate. The rear separator has the mounting lugs and the front one the motor mount.
There needs to be wiring to the gate to both power it and to select direction. The simplest possible two wires, reverse the polarity and the direction changes. It's possible to set the end points using micro switches, but they can be difficult to set and quite inconvenient. So I decided to use Hall effect probes as I did in my last project. The probes are on the fixed part and the sliding gate has a magnet embedded in it.
The circuit used is shown here. It's a symmetrical control system with blocking diodes so it will work in both polarities. It is built on a small piece of Vera board. Take a screenshot if it is of interest. I have color coded it to make operation understandable. The drive electronics mount on the 50mm port side on an attached lug, shown here. The sensors mount in holes to each side. Here you can see the magnet and sensor. Originally I was going to use a tooth belt drive, but that was overkill. So I settled for sprocket and chain, using Meccano chain. I did not have a sprocket small enough, so I hand cut one using 1/2" brass rod. Small rollers line up the chain. Running on 12 volts, it has plenty of power. Here I am testing the operation on a bench. To finish it off, I printed covers for the motor and electronics on one side and to cover the gears on the other side. Here it is in the finished condition.
With this gate now working, it's time to put the whole system together and test it out. That's for another time. Bye for now.